Hi guys, welcome back to the channel. In this video we are going to discuss asynchronous 3-bit 4-bit up counters. In the previous video we have already saw about introduction to the counters, types of counters and 2-bit counters. Now we are going to see this. Let's get started. So as you seeing there, this is 3-bit up ripple counter or asynchronous counter because all the the clock pulse is coming from the next previous outputs, not directly connected. So this is asynchronous circuit or asynchronous counter. So we can build with the DT, anything we can build, but I am using here JK flip-flop. So these connections also you can observe we have negative edge triggering for the JK flip-flop, and I am taking as a clock for the next second one. If you observe second flip-flop, I am taking clock as Q0. So this is simple, as if you observe the 2-bit flip-flop in the previous video, you can get to know about this. So the same thing, but I have attached another flip-flop, that's it. So as we have 3 flip-flops, we can store 3 bit of information, that is Q2, Q1, Q0. So if you are seeing the rightmost flip-flop, that is MSB, the Q2 is MSB, and the left one is the known as LSB, least significant bit, so that is Q0. You can represent Q2, Q1, Q0 as our output as shown there. As I am saying, in this video we are only going to discuss in the up counters, 3-bit up counter and 4-bit up counter. In the upcoming video we will also discuss 3-bit down counter, 4-bit down counter. So let's understand the up counter so that you can understand the down counter very easily. So if you observe, this is the up counter, it will start counting from 0 to 7 because this is the mod 8 counter. Total it has total 8 states starting from 0 to 7. So you can also see in the truth table that I am starting MSB and LSB are also written there. So Q2 is the MSB and Q0 is the LSB. So timing diagram analysis is very important. So now we are going to understand the timing diagram analysis. Timing diagram analysis might be asked in your university exams or college exams. Any might be asked that is very important. So startingly, as we have after total 8 clock pulses, the whole thing will be refreshed, or again it starts again from 0. So now if you observe, I have to total 8 clock pulses. So for the first clock pulse directly I am applying there. So we already know what is meant by edge triggering and level triggering. So in this we are going to have negative edge triggering. So at each edge we are going to corresponding our Q0, because at each edge level it is going to trigger our output Q0. So first of all, I in the first pulse we are having the negative edge. So there it becomes level high. The level means the second clock pulse, there it becomes level low. Like that you are going to take all the 8 pulses in the Q0. We are going to check and we are going to draw Q0. So in the same way, if you observe the third clock pulse, there also we have the falling edge. So there also we are going to react and we are going to have the high level again. So likewise, you are going to draw whole Q0 with the help of the falling edge with the clock pulse resembling. We are not going to draw Q0. So after drawing the Q0, you are going to see somewhat like this, because you are going to react at every clock edge, falling clock edge. So if you consider for the next flip-flop, that is second flip-flop, so that is second bit we are going to have, for that is Q1 output. We are going to draw for that also. So we are going to consider that clock. So if you see that the Q0 is clock for second flip-flop. So for that also we are going to consider Q0 as the falling edge, and we are going to consider that as a clock, the Q0 as a clock for the Q1, and we are going to draw for each and every falling edge of Q0, we are going to draw Q1. Let's see how to draw that. So this is the way that you are going to draw for the second flip-flop. The output is Q1 and the inputs are JK and the main clock. So if we are talking about ripple counters, all the counters is basic on the clock. So the clock manipulation is very important here. So you should understand the clock. So if you consider the clock is Q0, so simply just according to the Q0, take it as a clock and again draw Q1. So if you observe each and every falling edge, you are going to have a clock pulse up and down. So now we successfully completed our second bit, that is output Q1. Now we are going to move ahead for Q2, that is our third bit, that is 3-bit ripple counter, right, up counter. So for the third bit, that is the clock is Q1, the output is Q2, clock is Q1. So we are going to assume Q1 as our next clock for the building Q2 circuit, means the transition diagram. So if you see there we have 2 falling edges. So for that we are going to draw our Q2. In the same fashion, you are also going to draw for 2 falling edges. We are going to have for the first falling edge, we are going to rise high. For the next falling edge, you are again going to have low level. So this is the output Q2. If you have many more flip-flops, you can also expand or take Q2 as our clock and you can make our proceedings further. So this is the main thing, that if you have 4 flip-flops, you can have like this. Sorry, if you have 3 flip-flops, you can see like this. So in this video only we are going to understand for 4 flip-flops also. You can understand much more further. The next step is to verify our transition diagram, the timing diagram analysis is correct or not. So if you observe, we are going to label each and every level as 0 and 1, 0 and 1, so that it is very related to very easy to understand. So if you observe, if it is low level, marked as 0, if it is high level, marked as 1. Now we are going to have our truth table, that is MSB to LSB, Q2, Q1, Q0, and we are going to start from 0 to 1, that is from 0 to 7. Basically a up counter starting from 0 and it will count to 7, and again it has to come to 0, and likewise it has to count. Now we are going to observe each and every Q2, Q1, Q0 in the timing diagram analysis. So I have highlighted in a separate way red. If you observe first column, that means first column, that is 0, 0, 0, that is indicates 0. If you observe the second column, that is 0, 0, 1, that indicates 1. If you observe the next one, that is 0, 1, 0, that is 2. Likewise, if you see, that is going from starting from 0 to ending at 1, 1, 1, that is 7, and again coming to 0. So from the timing diagram analysis also we can understand it is a up counter. For understanding purpose, I have given like this. So if you observe here also, so the same thing that I have marked in boxes also. So first one corresponding to 0, next corresponding to 1, next corresponding to likewise, last one corresponding to 7. So again it comes to 0. So next clock pulse also will be same as it is, because starting from 0, then 1, then 2, again the same clock pulse will be continued for the next also. So we can conclude this counter counts from 0 to 7 and again count from 0 to 7, likewise it continues. So the next thing that we are going to see, the 4-bit up counter. So in this we are going to build with the help of T flip-flops. We can use JK also, but it is very simple to use T flip-flop. So that is why I am using T flip-flop. So if you see here also, even I took the 4 flip-flops also. The left side one is least significant bit and the right one is most significant bit. And you are going to represent the outputs in the format of Q3, Q2, Q1 and Q0. So here I used T flip-flops. So even though I use T flip-flops, I am sending all the inputs T as 1. Because if T is equal to 1 only, the output would be toggled. So output would be toggled. So then we have the negative, means this is the negative edge triggering, right? So that is the thing that we are T is passing 1. So as we have total 4 flip-flops, these 4 flip-flops can store 4 bit of information. So 4 bit means what? 2 power 4, total 16 combinations out of them we can get obtained. So starting from 0 to 15 we are going to have like this shown in the truth table also. So as we have total 16 states we can get. So from that we can get, this is the mod 16 counter. So total we can count 16 states starting from 0 to 15. For this also we are going to have the timing diagram analysis. So if you observe here, total we have 4 flip-flops. 4 flip-flops means total 16 states. 16 states means we are going to reset our flip-flops or counter. Our counter will be resetted after 16 states. After 16 clock pulse, again it will going to have start from 0. So 0 to 15, again it is starting from 0 to 15, like that it will going to count. So for simplicity purpose, I am going to have 16 clock pulses and directly passing into the clock. So let's see how to draw Q0, Q1, Q2, Q3 according to the clock. First of all, we need to draw our Q0. For Q0, we have a direct clock because we are passing direct clock into the first flip-flop and we are obtaining Q0. So for every falling edge of the clock, we are going to react our output Q and we have to change our levels. So for the first falling edge, we are going to react. For the second falling edge, we are going to react to the down level. And like that, you are going to have all the Q0 as same as first we have saw in the 3-way, means 3 flip-flops, 3-bit flip-flop. The same way we are going to obtain Q0. So the next thing is the second flip-flop. So for the second flip-flop, the output is Q1 and the clock is Q0 is. So the directly Q0 is clock is applied as the clock to the second flip-flop. So we have to react to the every clock or the every falling clock of the Q0. So if you see the first falling clock, we are going to react as up. For the second clock, falling clock of the Q0, we are going to fall down. Like that, we are going to change all the pulse of Q1. So similarly, for the third flip-flop, we are going to have the output Q2. So for the output Q2 or the third flip-flop, the clock is what? The clock is previous one because this is asynchronous one or ripple counter. So ripple counter or asynchronous counter, both are same. So the basic thing of ripple counter is what? The previous output is clock for the next one. So previous output is what? Here Q1. So Q1 will be our clock to the Q2. So for every falling edge of our Q1, we are going to react for the Q2 and we are going to draw for the same thing. And finally, we have our fourth flip-flop, that is output is Q3 and clock is the previous output, that is Q2. So with the help of clock Q2, we are going to have our output Q3. So we have two falling edges in the Q2. So according to the falling edges of Q2, we are going to consider our Q3, that is one high level and again low level at that. So the last falling edge, we are going to have the low level. So this is the output Q3 timing diagram analysis. Now we have to check this 4-bit ripple up counter. 4-bit ripple up counter means we are going to indicate all with zeros and ones. The low level is indicated with 0 and high level will be indicated with 1. So you are going to indicate all zeros and ones for all the levels. For Q0, Q1, Q2, Q3, you are going to represent all the way. And you are going to verify whether it is the correct up counting or not, because it has to start from 0, it has to end with 15, and again it has to start with 0 and end with 15, like that it has to count. And one more important thing, you have to see like Q3, Q2, Q1, Q0, because Q3 is here MSB and Q0 is LSB. So I have represented each and every one with a separate boxes, you can see over there. The first one Q3, Q2, Q1, Q0 is 0, 0, 0, 0, so that is 0. The next one is 0, 0, 0, 1, that is 1. The next one is 0, 0, 1, 0, that is 2. Like what it is going up to 15. The last one is 1, 1, 1, 1, that is 15. So starting from 0 ending at 15. So the same clockwise will be repeating. So if you also observe, that is 0. Again it will be going to 1, like that it will be going to repeat. So I hope you understood about 3-bit ripple counter up counter. So 4-bit ripple up counter. In the upcoming video, we are going to see 3-bit down counter, 4-bit ripple down counter as well. I hope you understood this video. Thanks for watching up to now.